Welcome to this video called Dependencies Basics. This video covers the basics of QFTest dependencies. It explains the purpose and intention of dependencies and shows how to implement a simple dependency. This video doesn't cover advanced topics such as nested dependencies, characteristic variables, or error handling. Those parts are discussed in other videos on this channel. For the current video, I work in a specially provided test suite, which you can also download from the QFTest website. The test suite uses the car configurator provided by QFTest in the web version as system under test. If you would like to work along with me during the video, you will find the suite in the commentary section. If you would prefer to see the result of this video straight away, you will also find that suite there. Now I opened the dependency test suite I just mentioned. Let's take a closer look at the implementation of it. Here you can see a test suite implemented in a simple way. We see a test set containing a setup node, a couple of test cases, and a cleanup node. The setup node will handle the starting of the application which we would like to test, in our case the car configurator. The cleanup node will close the application, and the test cases are actually selecting some vehicle models, some special models and further accessories, gaining a discount, and finally checking the calculation of the price. The setup node, the test cases, as well as the cleanup node consists of procedure calls. If we do a double click on such a procedure call, QFTest will jump to the procedures area, and there we see that the procedures are organized in a way that we see two packages: an SUT package, which handles the startup and the shutdown of the application which we are testing, and a car config package, which actually contains all procedures which we need for our test cases. However, those procedures are not of interest to us for the time being. Now that you are more or less familiar with our test suite, I will run the test cases from it. I select the test set, and then I press Start Test Run. QFTest now works its way through this test suite, and it executes the test cases with the various discount levels. We now wait until the test run is complete. The test execution is finished, and we can take a look at the QFTest run log to see what was going on. In the details of the run log, we can see that the first setup was run to start the SUT, then the first test case was executed, then the application was completely closed with the cleanup, then the application was restarted and the next test case was executed, and so on. As we can see here, on my system we need approximately 27 seconds to start the application. So a setup node will actually require 27 seconds, or in this part here 25 seconds. And the cleanup node mostly takes approximately 1 second. The whole thing of timing adds up, and this actually accounts for a large part of the total test run time, which we can also see in the performance view here. Particularly with larger applications, constantly stopping and starting the application would therefore be very inefficient and also does not represent real user behavior. In our case, this tidying up is actually unnecessary during a normal run of tests. The SUT has already been started and changes are reset in the test cases anyway. However, I cannot simply remove the cleanup node to solve the problem, otherwise the application would still run on the test machine forever after a test run. In addition, an error in the SUT in an unattended test run could compromise the entire test run instead of just a single test case. This shows the first disadvantage of this current implementation, namely that cleanup nodes are executed always at the end of every test case. Another disadvantage is that it's not easily possible to just start a single test case directly. For example, if a test case had thrown an exception during the last test run, either because this test was implemented incorrectly or because of a defect in the SUT, I cannot simply execute the test case again. I always have to run the setup to start the application first, and then I can run the test case again. Or I can create the preconditions manually, which ultimately means executing the setup again. Of course, this is still quite simple in this example, but also as soon as the test cases become larger and more complex, the entire setup can become quite tedious. So we see that we won't get very far with the current means. And now, QFTest dependencies enter the stage. Dependencies ensure that the preconditions for a test case are fulfilled if they are implemented correctly. This means that individual test cases can also be executed without having to create preconditions manually before. This also works if a completely different test case was previously executed. Dependencies also regulate the cleanup process and do not carry out any unnecessary cleanup work. To summarize, dependencies ensure a certain state, while setup and cleanup nodes only execute certain sequences. Let's get started and build a simple dependency. I will use the test set from earlier and simply copy it directly below. Of course, I should now rename the test set. For example, tests with dependencies. Now I insert a dependency node into the test set. To do this, I open the test set and then I either press Insert Dependencies Dependency, or I perform a right click to open the context menu and select Insert Node Dependencies Dependency. Now I name the whole thing appropriately. The prerequisite for our tests is that our system under test is running. So I can simply call the dependency something like SUT started. So this is actually the state which is being created by this dependency. Then I press OK. As I already mentioned, a dependency manages the setup and cleanup process. So our dependency should contain a setup node and a cleanup node. To do this, I drag the existing setup and cleanup nodes from our test set into that dependency. But why did I define the dependency at test set level? Actually, those steps belong to the test cases. Well, as you can see here in the test case attribute, each test case inherits the dependency from its parent node. In our case, each test case inherits the dependencies from this test set. It is therefore sufficient to define the dependency only at test set level, as this is automatically applied to all test cases containing it. And that's all we need to create our first dependency. So let's try it out. To do this, I need to make sure that no SUT is running. So I'll just press Run Reset Everything. As you can see, no client is active anymore, which means that our precondition, namely that the SUT should be started, is currently not fulfilled. If I now want to start a single test in our old test set, this won't be possible, and we will see that we will get some problems there. So if I start test case O from the previous test set, an exception will pop up immediately. Let's take a look at the details in the QFTest run log. In this case, I get an unbound variable exception, which actually means that there is an initial value of the client connection not being set. That's logical, because the variable is set by the setup node. And we reset the application before and we closed the application. And we haven't executed any setup node in between. Our new dependency, on the other hand, should now solve this problem. So let's try it. So I execute the first test case of our new test set and run it. And indeed, the test case has been executed without any problems, although the precondition was not fulfilled before the test case was started. But what exactly happened now? Let's take another look at the run log. As we can see, QFTest first looked at the dependency when the test case was started. For us, the entry required dependency is interesting. This entry here means that our test case, test count level O, requires the dependency SUT started in order to be executed. So QFTest jumps to the dependency and executes the setup node which we defined earlier, which means QFTest starts the SUT automatically. This approach makes it much easier now to try out individual test cases. Let's take a look at an entire run of the test set from the beginning. So I close the run log and I also reset everything in order to have no preconditions fulfilled. And now I execute the entire test set. What we can recognize immediately is that the execution was much faster than the one with our previous approach, and our application was not closed again between the individual test cases. We can see exactly what happened in the run log again. The impact on the duration of the test case can be seen directly again. By saving the closing and startup of the program around each test case, we saved around 25 seconds per test case from the second test case and 2 seconds for the first test case, and even 25 for the third test case. This is almost twice as fast as the first one. Let's figure out how the dependencies work. Nothing has changed in the first test case compared to the previous run log. The test case requires SUT started and executes the setup. It is interesting to note that no cleanup node is executed anywhere, not even at the end of the test set. This also explains why the car configurator did not close and reopen between the individual test cases. But why is this the case? To understand this, we should take a closer look at the functionality of dependencies. If our test cases are implemented with dependencies, their preconditions, which means the setup sequences, will be executed at the beginning in order to ensure the preconditions of each test case. QFTest keeps a list of those currently valid dependencies which can be recognized in the run log, namely under the entry stored dependencies. At the beginning of the first test case, this list is empty. That's why we don't see anything. Now the dependency is executed and QFTest saves this dependency in that particular list. From now on, every new test case which requires a dependency will compare the stored dependencies with the required dependencies of the individual test case. If the stored dependencies and the required dependencies match, as we see in the second test case, the cleanup action is skipped and not being executed. For QFTest, it looks like that the test case requires the same precondition as the previous test case, and so there is no need to run the cleanup. So this means at the beginning of every test case, QFTest decides whether it's necessary to run the cleanup or to skip it. Between two test cases, the setup node of our current dependency is executed again in any case. Finally, we want to ensure that our preconditions are still fulfilled and have not been lost in between, for example due to a manual interaction or due to a crash of the SUT. It is therefore also important that the setup node of a dependency is implemented in a well-thought manner. As a rule for this, a setup node should do the following. It should start the SUT, but only do that if it's not already running. Fortunately, this is already implemented in our test suite. For demonstration purposes, I will just jump to this node, selecting the setup node, performing a right click and press Find Node in Test Suite. Here we find the procedure to start the SUT. I jump to the procedure via a double click. And here we can see a Verify Client Connection node, which actually checks whether the car configurator is already running. The result of this node is stored in the variable isSUT_running, and this variable is then evaluated in the subsequent if node, and if no SUT is running, the browser will be started in our case. It is important to remember that this process always takes place at the beginning of a test case. After that, the setup and cleanup nodes of a dependency no longer affects the process. Please note that such setup nodes will be automatically created by the Quick Start wizard. As already mentioned, the setup sequence of a dependency is executed before each test case, and the cleanup nodes only when required. And to understand this functionality more in detail, let's take a look at it in action. I have now prepared another test set, which is using a different dependency, the so-called another dependency. This test set and the test cases in it are just implemented for demonstration purposes, so they actually do nothing, just printing out wherever they are. The goal of this test set and those test cases is just to show how QFTest handles the execution of test cases with different dependencies. Let's simply execute the test set. After the execution, we will open the one-log again, and let's figure out the details of that execution. In the details of the dependency of the first test case, we see that the SUT started dependency is still being saved, which is the list of the fulfilled dependencies from the previous test one. We see that the another dependency is the required one. So now QFTest recognizes that the dependency SUT started is not necessary anymore, and that's why the cleanup is being triggered. QFTest could know beforehand whether it would make sense to clean up the dependency now. After all, we could just have executed another test case with the dependency SUT started, which would not have triggered the cleanup. The dependency another dependency is then being prepared and the test case is being executed accordingly. The second test case of this test set has then just the comparison of another dependency, which is the stored one, and the required another dependency, which actually raises no further cleanup action. And because of this algorithm, we can now combine arbitrary test cases and test sets from various test suites, as long as they also have dependencies being implemented. QFTest will cleverly clean up previous dependencies and fulfill the required preconditions. The last point which I would like to address in this video is the point of reusing dependencies. So how could I reuse dependencies and use the dependency multiple times for different test sets and so on? Of course, you could copy the dependency from the test set to another test set or to another test case and so on. But however, if the dependency should change because of a new error handling or whatever, we need to update all those locations. By the way, adding error handling to dependencies will be covered in another video. But if we need to update every copy of this dependency, it will be quite tedious. Fortunately, QFTest allows us to store a dependency in the procedures area. So therefore I open the procedures and I then select Insert Dependencies Dependency, which I could also reach via the context menu. And then I can define a name like SUT started again and move the setup and cleanup node from our previous dependencies to it. And then I can get rid of the existing dependency. Of course, I could have move the entire dependency down to the procedures via drag and drop. In order to refer to that dependency now, we need to add a dependency reference node, which we could achieve by selecting the test set and selecting Insert Dependency Dependency Reference. And this node actually works like a procedure call. So we click the selection button, choose the dependency, and confirm. Inserting a dependency reference also works like inserting a procedure call, so I could also have used a drag and drop action here. The dependency reference node works the same way as the dependency node. In the end of the day, it's just a link to the existing dependency, which is located in the procedures now. And that's it for the basic knowledge of dependencies. I hope I was able to enlighten you in using dependencies. In a follow-up video, we will look at the use of nested dependencies and error and exception handling. If you have any further questions about dependencies or QFTest, I would like to refer you to our other videos, tutorial, and our comprehensive and always up-to-date manual. The next step to you is to check your own QFTest test suites and projects to see whether dependencies can be utilized or are already used. The efforts will definitely be worth it.